This is the second part of lesson 3.3 on multiplying two binomials. And I'm actually going to just pop back to the last part of the first half of the lesson, this part. Just want you to see that when we multiplied this together, we multiplied everything times everything. So we multiplied the A times the C, which is right there, and we multiplied the A times the D, and then we multiplied the B times the C, and the B times the D. So the overall plan when you're multiplying two polynomials is everything in the first times everything in the last, or in the second one, okay? And actually, I realize now that that's what this says here. So yeah, we get everything times everything. So we have an acronym for this to remind you of this, and it's FOIL, F-O-I-L. This is actually written down after we do these examples. I'm not sure why, but the F is the first term in each bracket. So it's A times C, and O is the, well, actually we usually draw this in lines. So if we've got A plus B times C plus D, it's the first is the first times the first, and then the outer is the outer one times the outer, like the outside ones times each other. And then we have the inside, so the inside times the inside, and then the last times the last, like that. And that is a handy acronym when we're learning this, but the real rule is everything in the first factor, which is here, what's in the brackets, A plus B. So everything in here times everything in the next one. So the A goes times the C and then times the D, and then the B times the C and times the D. Okay, but FOIL is the acronym that you'll hear us use all the time. Okay, so let's do this. So I'm going to go x times x is x squared, and then x times 2 is going to be plus 2x, and then x times 3 is plus 3x, and 3 times 2 is plus 6, and then we're going to simplify that. That's x squared plus 5x plus 6. Okay? And we're just going to hop back up here for a minute and look at this. This is the same product, same multiplication that we did. And so if we multiply we've got the x times x plus 3, we did x times x got us the x squared, and now let me try it this way. So the x times x got us the x squared here, and then the x plus 2, or x times 2, got us these ones, and then the 3 times x got us these ones, and the 3 times 2 got us, I should have done this in color, got us these ones. So you see, we got the same pieces when we did this with algebra tiles. We just are doing it now with numbers and symbols instead of using the algebra tiles. But the algebra tiles let you visualize it better, okay? And then there was an example here. We did actually the same thing using the rectangle diagram, where we've got x plus 3 and x plus 2. We've got x squared, there's the 3x, there's the 2x, there's the 6. And then we added together the like terms, the 3x and the 2x, to get the 5x. Okay, so it's the same thing. But the algebra tiles and so on are really helpful when you're learning to make sense of this, but you're not going to draw those out when you're doing higher level maths, where this just becomes an absolute tool that you use all the time. Okay, so let's go back to our FOIL. So first outer, so a times 2a is 2a squared. A times -1 is minus a, and then inner last. Minus 7 times 2a is minus 14a, and -7 times -1 is plus 7. So that's 2a squared minus 15a plus 7. Okay, why don't you try this next one? So we get p squared minus 8p minus 8q plus 64. And this one we can't simplify anything because there are no like terms. The P and the Q are not the same. All right. Next one. X times X is X squared. X minus 5, X times negative 5y, Y is minus 5xy. 4y times X is plus 4xy. Notice that I put them in the same order. I don't go minus 4yx. It's not wrong to go 4yx. Those are equal, but the convention, as I mentioned, is to do them in alphabetical order. And it also makes it obvious that these are like terms that we are going to be able to combine when we're finished. Finish this line. Okay, and then we've got 4y times minus 5y is minus 20y squared. And then, like I said, we've got these two like terms here, so we can simplify this to x squared minus xy minus 20y squared. Okay, one more example. What color do I want to do this one in? So this is going to be 45 a to the 5. See how we need those exponent rules? And then this is 9 times 6 is 56. So we have 56 plus 56a squared. And then negative 1 times 5a is minus, 5a cubed. And then minus 6. And again, we can't simplify that one. Okay. But I do want to show you how to check, okay, because checking your answers is really important. And the best way to check these is to substitute in another value. So I'm going to go to check. I'm going to make a equal 2. Now you can make a equal anything you want, but because the premise here is that what we started with is equal to what we ended with. It just looks different. It's a different shape, different presentation of the values or the expression. You don't want to use 1 as your value because 1 cubed and 1 to the 5th and 1 to the 5 are all the same thing. And so if you've made a mistake with your exponents, it won't turn up if you use 1 for your value. And of course, you don't want to use 0 because a whole bunch of things disappear if you use 0. So 2 is a good value. I mean, you could use 312.4, but that would be, silly. So let's use 2. So if I come down to the bottom bit here and I go, that's 2. So this is going to be 45 times 32 plus 56 times 4 minus 5 times 8 minus 6. Now, do you use a calculator for this? Yes and no. I would do that piece of it without a calculator because I know those number facts. I have them cold. I know I'm not going to make a mistake on them. Hopefully, I'm not going to make a mistake on them. And it's easier to do it in my head at that point than to do it with a calculator. But now I don't know what 45 times 32 is, so now I'm going to pick up my calculator, and that's 1440 plus 216 minus 40 minus 6, and then I put that all in my calculator, and I get 1610. And then I come up here, and I'm going to do this part using the same value of 2. So this is going to be 9 times 4 minus 1 times 5 times 8 plus 6. So that's 36 minus 1. That's 35 times 40 plus 6 is 46. And then I'm going to pick up my calculator, and that gets me 1610. Which is what I got down here. So yeah, I'm happy I got the same thing. Now, can I find my answer in here? It's kind of buried in there. So I'm going to put a box around it so that I'm really clear on what my answer was, and whoever's marking my work knows what my answer is. Okay? Okay, just a few more examples real quick. There's one that I want to do. These are just more of the same, so I will fill them in after, but I'm going to have people in my room in a minute, so I want to finish this up. When you see one like this, it's really important that you don't shortcut it. This has got to be 6a minus 5b times 6a minus 5b. Don't don't try and do it without writing that out. Okay, just don't do it. You will. So many students, they end up squaring this and then squaring this and they miss the middle part. So please, please, please don't do that. So now we're going to FOIL this. This is going to be 36a squared minus 30ab minus another 30ab and then plus 25b. So this is 36a squared minus 60ab plus 25b. Okay, there you go. I'll fill in the rest in silence.